Hello, everyone, and good morning. We have a couple of things to go over because they were requested of me, and I wanted to make a video because it's easier to explain these topics in video than it would be to just send notes out. So if you are struggling with geometric mean or trig functions for angles and sides, these are common things that you're going to be doing in upper level geometry and then trig and pre-calculus. So we're going to go through two quick problems that were sent to me. And then if you're still struggling with it after that, let me know and we can go through some more. So first and foremost, let's talk about what these trig functions look like when it comes to a triangle. Well, every triangle, well, it's called a triangle because there's three angles, okay? So with these three angles, you can always find three things: sine, cosine, and tangent. In order to find these items, you're going to need some specific information. You're going to need to know what these things are. Well, let's say that we're dealing with um, some angle X here. Okay. So for angle X, when we think about the opposite of angle X, that's going to be here. When we think about the adjacent of angle X, that's going to be right here. Adjacent is right next to. And then we think about the hypotenuse of angle X, that's going to be directly across from your 90-degree angle. Hypotenuse should be familiar because we've dealt with that in Pythagorean theorem. And by this point, you should have already done plenty of things with right triangles. So if you're given angle X and you're looking for one of these things, you have sine equals, you can remember this acronym, SOHCAHTOA. What SO is opposite over hypotenuse. So all you need is your opposite side length over hypotenuse to find your angle sine. If you're given the angle, which you'll see here in a minute, how to manipulate this equation to find one of your missing pieces. So you can use this to find any of the missing pieces. Cosine is going to be adjacent over hypotenuse. So again, if we're dealing with angle X, cosine of angle X would be this red side over the green side, okay? And then tangent, TOA, opposite over adjacent. So SOHCAHTOA tells you exactly what pieces of the puzzle you need from your triangle. So with this in mind, we can solve our first problem. Our first problem tells us to find X. Well, we're given, of course, our 90-degree angle. We're given one side, 3 times the square root of 2. And then we're given X, and we're given a 45-degree angle. So let's think about what we're given here. We know our hypotenuse is X. We know our opposite is 3 square root of 2, and we know our angle. So when you're dealing with SOHCAHTOA, which one of these are we given enough information for? Well, we have the hypotenuse and we have the opposite. Automatically, I know I'm dealing with a sine problem. Okay? So let's fill in what we know. Sine of our 45-degree angle, because sine always has an angle associated with it, because sine is written as sine theta, right? And theta is any angle measure. We're given the angle measure. So sine times 45 equals opposite over hypotenuse. And now we're just dealing with any normal equation, okay? So we need to figure out a way to solve for X. And in its current form, I can't solve for X. But what I can do is start working to get X by itself. Well, if 3 times square root of 2 is being divided by x. The opposite of division is multiplication. So I can multiply by x, and that gets rid of those here. Well, what I do to one side of the equal sign, I have to do to the other. So times x. So this now becomes x sine 45 equals 3 square root of 2. Well, we have x times sine 45 equals 3 times square root of 2. What else can we do here? Well, x times sine 45, we can divide by sine of that 45-degree angle here. It goes away. We do to one side of the equal, we have to do to the other. And now we have x equals this crazy thing here. Well, I don't expect you to do sine by hand. If you don't have a scientific calculator or a TI 33, 34, any of those at your disposal, you can go to Desmos Scientific, and that's just desmos.com/scientific. And you can type in exactly what you need here. So we said 3 square root of 2 divided by, not that, divided by all of that divided by sine 45. Enter. And it gives you 6. So 3 times square root of 2 divided by sine 45 gives us a nice, easy, clean angle measure of 6. And that is exactly how you would approach this problem every single time. And even if your angle measure was x, but we had the opposite over hypotenuse, and we need to know what sine x is, well, all you do is 3 times square root of 2 divided by 6. And it says that. Well, we know that sine is 45 degrees. Are those two equal? 100%. So you can easily, there are some conversions to convert this to angle measures that we can talk about if you all need to see that. And it all comes back to the unit circle and things like that. But we can certainly talk about that if you have a problem that you need to see. So this is how I would approach this problem to solve for x and any problem where I'm missing a side measure. Next, this one cleans up a little bit easier and a little bit quicker. Find geometric mean between 1/2 and 2. Anytime you're dealing with geometric mean, your geometric mean is just the square root of a times b. A times b meaning the two numbers we're given. So we have the square root or radical 1/2 times 2. Well, 1/2 times 2 is the square root of 1. The square root of 1 is 1. So, and just to check that, if you wanted to, you could do square root of 1 equals 1. Again, this calculator completely free to use, desmos.com/scientific. This is the formula you're going to use for geometric mean every time. Remember, SOHCAHTOA as this, and you'll be able to solve your triangle angle measures. If you have any questions or you want to see more examples, reach out. I'll be happy to help. Otherwise, good luck working with trig.